Hello, everyone, and welcome to Not Just AI podcast. My name is Pranay Agrawal. I'm a co-founder and CEO at Fractal. At Fractal, our mission is to convert AI excitement into enterprise performance, and we do that by solving the most important enterprise issues, problems using AI engineering and design. Today, we have two incredible guests, pioneers in the field of AI, Tom Gruber and Ben Vigoda. Tom Gruber is the co-founder and inventor of arguably the most popular person in the world, Siri. Tom is very interested in the area of humanistic AI, and he believes that AI will augment human intelligence rather than replace it. Joining Tom on this conversation, we have Ben Vigoda. Ben Vigoda is an innovator in the area of probabilistic programming and hardware. He's a scientist and entrepreneur, founder of companies such as Lyric Semiconductor, Gamelon, and Product Genius. He's also a founder of nonprofit company called Design That Matters, which is creating medical devices, low-cost medical devices for underserved communities. So such a pleasure to have both of you here today with me. And Tom, I want to start with you. Let me ask you this. What was your inspiration for creating Siri? And did the creation meet your vision? And then I have one more question for you.
Yeah, no,
Given
fine.
all the advancements that we've had in AI and in LLMs in the last 2 to 3 years, how would you change Siri today?
Wow, okay. Yeah. So the inspiration for creating Siri was, well, it was the late 2000 knots, I mean the 2007, 2008. And we
Yeah,
had just seen the Web 2.0 era in which there was this amazing bounty of user contributed content, Google Maps and Yelp and all this had come up. And if you had 10 fingers and a big screen and an internet connection, you could get amazing stuff done, right?
yeah,
But when the iPhone 1 had just been released, late 2007, and the mobile era was about to happen. And
yeah.
so we sort of saw that coming. One of our co-founders was in the mobile industry. He could see that coming. And when we said, like, hey, why don't we, but we can't use the bounty of all this stuff on the internet with this tiny little phone. So let's make the appropriate interface. So then we decided, well, we know how to do this. It's a conversational interface. It just hasn't been done yet. We've been waiting since the 1980s to do one of these. And so so we put together a team and the vision, and it just clicked. And then once we knew we wanted to make a usable interface for everyone, a universal design that anyone could use, it just became its own momentum. Like, let's make it as easy as possible. Let's make it so anyone can use it. And they don't have to even type or touch or anything. Just anyone can use it with their voice. They don't have to know what the commands are. They just have to say anything. And that just essentially approached what an AI assistant does, in terms of the interface. So we're really happy with the way what we'd call the conversational interface paradigm came out. It's essentially still stable after 10, 15 years. People still use the same model, basically. It's just today it goes on for as long as you want. In Siri days, it only goes for 1 or 2 replies. But we all wanted it to go as long as, eventually to go, that's the idea. But the main thing is you can ask questions. It's a conversation, not just a command line, right? So if we had LLMs back then, and remember, we didn't even have deep learning back then.
Exactly.
So this is before the Hinton thing you're talking about. All this, this is before speech and vision had been conquered by deep nets.
So if we just stay on that for one moment, right?
Yeah.
So what was the underlying technology that you used over there? Like you said, we didn't have deep learning at the scale at which we do today. We didn't have LLMs. So how did you make this work? I mean, what was going on underneath?
Yeah, well, I mean, I've been doing AI since the 80s, since the early 80s, and I'm what they call a good old-fashioned AI guy. And what we use is symbolic reasoning. And it's essentially a form of, today you might look back and say, it's very sophisticated software engineering, where you represent the knowledge you want to put, the expertise, the way, the knowledge and the way, the smarts, you represent it in data structures, knowledge representations and so on that the machine can understand. And you engineer it deliberately that way. And the thing about it is no one had done it before, because that's actually hard to do for something as complicated as an assistant. So we kind of thought of the Siri project as kind of like building the first commercial airline. So you could license the jet engine from like a speech synthesis company, speech recognition company. You could license the airfoil from maybe, this other company. You can use Java for the programming language and so on. And the avionics, we kind of did our own avionics. And then, we put it all together, and system integration is hard. You had the Wright brothers, then you had a while before you had commercial aircraft. And so we're very proud of the fact that we were able to get, for example, when you did one query for a restaurant, you called 7 or 8 commercial APIs within less than a second on the internet, gathered all the everything together and gave the answer in natural language response in the cloud. And so one of the other pieces of this commercial infrastructure was that something your company is good at, doing cloud infrastructure. Well, in late 2008, 2009, that was kind of a new thing. And so we were really happy to use all those parts. So that's really what we ended up doing. That was the way we pulled it off. Now, how did we do natural language understanding and speech understanding? Well, speech understanding was a statistical speech understanding as it is today. It's just that it was trained with the technology at the time, essentially very small amount of data, which meant that you can only use certain kinds of models. And we predicted that if we got this flywheel going of increasing the number of users by putting it online with mobile users, we'd be able to get lots of data, which would improve the model significantly. And that prediction was also correct. It happened to be true. So we were making a bet that the future speech recognition wouldn't be good enough. And we were making a bet about the future bandwidth would be good enough. Because at the beginning, it was 2G on AT&T Mobile in the United States. It was pretty bad bandwidth. But a year or two later, it started to pick up. So essentially, lessons for, say, entrepreneurs or for, say, a corporate technology planner is essentially a lot of these big breakthrough things like a Siri is really about recognizing where we are in history and get bets about where we're going to be in a few years and placing the technology bets so that we're there when it lands.
I think that's amazing that you need to be able to place some bets on where the technology is going to be in the future. And at that time, did you have a bet on LLMs getting as good as they are today? And what would you do with Siri today with the LLMs and the reasoning models that are available?
That's a good question. Well, the phrase hadn't really been invented yet in LLM, but actually I did a little language model in 1983. It did autocomplete for people who couldn't speak with their mouth. So it uses a switch or something, and it would autocomplete into a language model. So it would accelerate their ability to speak. And we used Apple IIe on a wheelchair. It was a language model. It was an autocomplete. It was all the things you'd say, but it fit on an Apple IIe, which was about 32K or something like that, whatever.
Okay.
So the idea was there. When we got to Siri, we did what was called a semantic autocomplete. It was a similar idea where you have a language model again. This time it's based on grammars. The grammars of all the ways that we knew that we could recognize the commands that people would say. And then as they typed or spoke, it would autocomplete, but this time with the meaning, like a place, like a city you're in, or a restaurant, or the semantics, not just the strings. And that actually worked quite well as well to help teach people how to use it. So these ideas of autoencoder or autocomplete language models have been around for a long time, but we didn't have LLMs. But we did kind of count on, when we decided to join Apple, we were kind of saying, okay, we're going to let them take care of the business, even though we had a great business, different story. And we're going to work on the future product. And that was exciting because we thought we're going to have a lot of opportunity with that many users to build a future product. And sure enough, a few years later, they were able to take the deep learning speech recognizing technology and the giant amount of data we had and vastly improve the speech recognition. So now, and in fact, today for the last several years, you step back, it's better than humans. This speech recognition is now. So we're really pleased with the way they went.
Amazing. Siri is certainly the most popular person in the world now. So
scary, isn't it?
So Ben, question for you now. Then you created this concept of probabilistic programming, right? Tell us a little bit about it. What does it mean, and how does it sit against LLMs or with LLMs? And where is one useful? Where is the other useful? And how do you see the future of the two?
Well, this is actually how I met Tom at Apple. But even before that, I had, like Tom, been doing this stuff for a long time. So the summer I turned 14, I interned with David Rumelhart, a professor at Stanford, who's famous for creating the backpropagation algorithm, or rediscovering it, but applying it to deep learning. And kind of got bitten by the bug and never went back. And so when I did my PhD at MIT, I ended up working on circuits. What I wrote in my thesis was that if all of the neurons in our brains are used for planning and inference and so forth, then probably the majority of transistors will be used for that in the future too. And so I started working. There was no such thing as a AI hardware accelerator back then. So, we created, and then the spin out that we created from that, created some of the first tensor processing units. They were tensor accelerators. They had a way of accessing the weights of the model, the neural weights, through a dedicated bus, and modeling environment like very early version of like TensorFlow and compiler. So really doing the whole stack, and collaborating with Google actually through their early days, a bunch of years before they announced the TPU. And so what I started to see coming, and how Tom and I came to be collaborating within Siri, was that, since the 90s, people like Moravec and Kurzweil were predicting we'd have $1,000 computer that was as powerful as a human brain. They used dates like 2020, which turned out not to be the case. But in 2014, when I did my TED talk, I calculated 2046. And then I realized, because I'd been building these processors, that it was going to be 2036, because we were going to get 10 years of advantage from the chips. So similar to what Tom was saying about sort of looking forward, what's coming. And now actually I just redid the calculation. We're exactly on track. Part of that was figuring out a design language for how to develop these models. And so co-developed probabilistic programming with Noah Goodman at Stanford, and several other great folks who were part of a DARPA program that we were innovating. But we were very interested in interpretability, explainability, and designability of deep learning models. And that was the thinking there, was how do we really conceptualize what's going on inside the LLMs. We were building large text models. We were analyzing, at the time, millions of Siri inputs to see what people were using Siri for. And that explainability, that ability to design for that was really key.
Yeah. So yes, I think what I also understand is that the entire area of probabilistic programming has more explainability, right? And therefore, in that context, how would you sort of put them up against like LLMs, which I think don't have that much explainability, right? And what would you say? Where would you apply one versus the other?
So if you take a probabilistic program, as we've done recently at MIT, and compile it into a deep learning system, if you've implemented in with Jackson Flax, say your favorite neural network library, and you run backprop on it, then you get a transformer model out, because we can talk more about that. But and so actually the probabilistic programs we were writing in 2014 were actually transformers, very, very similar to the Vaswani et al. Work. And but what I think is novel here is that you could design in different humans have different personalities. You could train two different babies on the exact same data sets and get very different humans. And so, we were interested in designing in logical hierarchies. So how do we make it so these systems learn deep and logically organized concepts rather than leaving it to chance?
What's called inductive bias is the key here. So that the machine, two babies analogy is good. You have the same learning experience, the same data, different baby. Well, that's actually the nature part of nature nurture. The genetics, the genome, or whatever of the baby. In this case, an inductive bias is what's making the machine learning just learn a certain kind of thing versus another kind of thing exposed to the same data. And so the insight that Noah and Ben and the other people in that field, Josh Tenenbaum, were finding is that there is real power in hierarchy and logical organization and compositionality. Those are concepts not just for programmers and logicians, but for all of us. We use this. You use it in your work all the time at Fractal, in organizing things into these, it's a sensible organizing principle for intelligence. And so by deliberately saying we want to use that, we want to guide the induction to take advantage of those principles, it created a vastly more accelerated kind of learning. Learning that requires much less data than traditional a 10, 20, 50 billion parameter LLM. It also can be explained, because to the extent that there's a bit of you can kind of say, well, we kind of went up this hierarchy. We had this logical thing going on. It's not good old-fashioned AI, but it has some of the elements that made good old-fashioned AI work, which is sort of structured logic and structured hierarchy. And so that's why I was excited about it when we started working together. Over the years, we've seen that it's pivoted now, and it's proving to be, even formally equivalent to LLMs that are much more expensive to build and much more expensive and slower to run, but effectively get the advantage of all this explainability and transparency.
Yeah, I really like the two baby analogy. Though of course, whatever we may do, I think two kids will never have the same experiences as much as we may put them through exactly the same environment. And then there is of course the element of nature, which means that their brains have come wired differently, right?
Exactly.
But if we look at technology, would you expect that two sets of algorithms could come up with different experiences or different wiring, even though they were exposed to the same learning and same data?
Yeah, exactly. So another baby analogy is, we look at antelope babies and we're impressed that they, come right out of the mother and they're standing and walking around within, a few minutes. And why lions, they have to be able to walk very quickly, very soon after being born. And, we're impressed because we say, well, how do they learn to do that with so little training data? They've only been alive a few minutes. Well, the AI moms should be really jealous of us because our babies have only seen about 150 million words. If they think, at a 12-year-old kid, human kid, this is the 150 million words, one word a second, day, night, 24/7, 365. And they're already able to really reason and think and do a lot of impressive things that the AI moms would be great for them if their babies could do that. But the AI babies take trillions of training words before they get arguably to the point of being a 12-year-old. So there is something beyond just data. We have this
The bitter lesson.
The bitter lesson. Thank you. Yeah. Substitute. And so, so there's been a kind of a pendulum swing toward there's only data and there's nothing else to think about. But if that were the case, then we'd still be using perceptrons instead of transformers, right? The architecture does matter.
Which gives us room for a lot of optimism, actually, too. The fact is that we're doing it the really, really brute force way right now in AI. And we know for these existence proofs, right, that we can have much better inductive bias than that. We can make learners that are much more learn quicker on less data and more explainable. We just have to find those algorithms. And so there's lots of work for AI scientists yet to do, despite the talk of automating them away.
All that has been done, right?
Yeah.
Excellent. So that's a good segue into the next topic, right? Because you said AI moms should be really envious of human moms, right? Tom, you have had this concept of humanistic AI, and various points of time you said that every time a machine gets smarter, human gets smarter. Don't ask how you can make the machine smarter. Ask how can the machine make us smarter. What do you mean when you say all of this, right? I mean, it all kinds of, points towards a theme of like human at the center of all of this AI development. So tell us a little bit about it. Throw some light on this.
I mean, the humanistic in the sense of the humanist philosophers and poets and writers and so on, and sense that, yes, humans are at the center, should be at the center of this technology movement, I think. And it's a philosophy, and you can choose otherwise. A counter philosophy might be, no, the job of AI is to automate human knowledge work and take over economic power. That's some people's goals, right? We've heard it said in public, in daylight. We're going to automate all the knowledge workers in the world. Well, that's an interesting goal, but humanistic AI says the goal ought to be to solve human needs, solve problems that humans already want to solve, and there's plenty of them to go around, right? There's no shortage of important problems to solve, business or society or health or whatever. And in so doing, do it by augmenting what humans do. not always have a human in a loop for every process, but augment what humans do. So, these glasses augment my vision. I have almost perfect vision. I still like it to see a little better, but then I want to see a microscope. I want to see a microbe. I see put a microscope on. I want to see a galaxy. I put a telescope on. And those are augmentations. And so AI can be like the microscope or the telescope, and they can open our eyes to new ideas and new things, but it's still us looking through. That's not for no romantic reasons. It's because we want to understand those things. We want to solve those problems in physics or whatever. So that's the basic philosophy. And the way it actually, people have asked, like, so who cares? It's a philosophy. That's very nice. Be good to humans. Okay. But actually in practice, it really makes a difference. I understand a little bit from what you said about your business. You advise a lot of important clients about, like, what are they going to do with their big AI budgets? How are they going to use AI? Their CEOs go, give me some of that AI. I want it. I want to see impact. Well, you can always go back and clean up and say, I got a 10% improvement in productivity in XYZ process later on. Okay. That's uninteresting work. This is the time now where we have the opportunity to solve really big unsolved problems. And this is why, the people at Google are like, we're going to solve material science problems. We're going to solve biology problems. We're going to solve nuclear fusion problems. These are the times to solve the important problems. And there are problems like that in business too, that are not just cut off some of the labor force, save a few dollars here and there. And I think when we choose, there's a double-edged good side to that, is that not only if you do that, you're going to probably have a better impact on humanity than just saving money or whatever, but also you can be aligned around the mission so that when things change, and they always do, the technology changes, the political environment changes, even your assumptions about the problem nature change, all these things, you can pivot because your North Star is an actual problem in the world, not just like making AGI or automating work or something like that. And so that's the philosophy. And I've found that it actually, it can go from scale from all the way down to, like, what is a grad student going to do for their PhD, all the way up to what's an enterprise going to do for the $100 million project.
I think that's so true. I certainly connect with that because there are so many big problems to be solved. In a small way, as an example, Fractal, we created a product called Cure, Qure.ai, that does diagnosis on chest X-rays to provide
Nice.
a diagnosis in under a minute, 99% accurate for just $1 a scan for tuberculosis and now for lung cancer. And of course, the problems to be solved are infinite, right? So yes, I think it's about the human at the center and making things better and solving big problems, right? And so, Ben, if I turn the same question over to you, and specifically with this notion, which is so important, of transparency, and and you link that back to your probabilistic model idea. What are your thoughts on this?
Well, I can tell you some of the things that I've been involved in that I'm excited about and that I see big problems to be solved. One is the transparency of the algorithms that drive information to us, things like social media. So one of the projects I'm involved in is an AI that learns faster. It's very explicit about what it learns, and one of the applications is creating a TikTok-like feed, or an Instagram-like feed. But imagine if you could tell the algorithm is not owned behind closed doors, but it's not their algorithm, it's your algorithm. So be able to talk directly to the AI and transparently tell it what you're interested in having in your information feed. And then it also says, well, you've been scrolling on this and that, and I've intuited that and learned that you're interested in this and this other thing. And you can tell it, no, I don't agree with that. I don't want to see those things. I want to see these other things. And so
taking a little
that's
bit more
one example of that.
of the algorithms, giving the user more agency in the algorithms.
Yeah, exactly. Another example of this is actually in shopping, which is a wonderful business application. There are, the big tech players who have, shopping interfaces, and there's also $6.1 trillion every year of online commerce that isn't through the big tech players, other businesses, and they don't really have access to the kinds of algorithms for really creating an AI-powered shopping experience. So it's the business who's really cares about their brand, and they can never hire enough humans to interact with every customer, one-on-one. They would love to be able to really serve every customer excellently. But to hand that over to an AI means they have to have full transparency. They really have to understand what's happening when those customers are interacting with their brand. And so that's another really great example of, a really big problem, helping, in many of the businesses we work with are actually growth businesses. They might be selling through a Shopify store,
Yeah.
other e-commerce platforms. So they're middle-class folks. They're trying to build their businesses and being able to build their brand and have access to the kinds of technology that the big players have.
So in a way, helping level the playing field a little bit with the use of
Right.
technology. And which actually drives me
Absolutely.
to my next question, which is that we are speaking a lot about access and creating access. And do you believe that access equals democratization, or is there more to it?
For me, well, democratization and proliferation are two sides of the same coin. So,
Okay.
just to observe what might happen, I think that we're likely to see smaller, cheaper, and more ubiquitous and smarter models as time goes on. And if we do get $1,000 machine that is as powerful as the human brain by 2036, then that means in just the next few years, scientists and high school students and undergraduate engineering students all over the world are going to have these computers networked, and they have their own GPUs and so forth, and they're going to be making all kinds of advances of the kind that only fewer people were able to make. Now they have AIs, they can help them learn the field. So it'll be interesting to see what comes first. Is it the nuclear power plant, the 100 nuclear power plants and the 100 million square foot data center in the desert that trains the Uber model? Or is it people in India and many other countries who are innovating, and they come up with models on their own laptops? So today, with a little help go to your favorite AI, you can actually download a very advanced state-of-the-art model and run it on your MacBook Pro. So, you could run GPT-5 Mini on your MacBook Pro right now, and you wouldn't share any of your private data with anybody in particular, and you wouldn't pay your $20 a month ever again. So it's going to be very, very interesting to see how this unfolds. But I think any idea of how it unfolds and how we govern it or think about it has to contemplate, this collective intelligence.
Yeah. And so I think what I'm taking away from this, and Tom, I'd love your point of view on this as well, which is that while access is very important, true democratization will be when that access comes with the ability to control and guide in a particular way.
Absolutely, yeah. In fact, I'm really a fan of the phrase universal access, which Apple used to use a lot in the 80s and 90s that referred to what they call accessibility today, which is the goal is that everyone should be able to use the technology, to use all the features of the product, no matter what your abilities, temporary or permanent impairments, it doesn't matter. And so when we built Siri, we built it that way, as a universal design product, so that you could use it whether you're, for instance, cognitively impaired with no hands, and limited vision, in other words, driving. You should be able to use it that way. And of course, people who are paraplegic and blind actually could use it as well. But that means the drivers could use it, right? And so universal design is a thing that I think, and designing for universal access is a thing that AI enables. It is the first time that, what's really great about LLMs is that they have one superpower, which is language. But if you had to choose one, it's the best one. I hear you're going to make one superpower in math too. That's good. But because the current ones aren't as good at math, as you know. But they're English majors, right? They're tremendous liberal arts majors. And that's a good one because everybody speaks natural language.
Yeah.
And so it is a universal language. And so it's democratizing in that sense. Now, the learning that society has to go through is, how does it work when everybody has their own? What does that mean? I think back to when, the first quote personal computers came out. That was a real social movement, as you remember. It was like a big deal in Silicon Valley. These were like people who would do LSD and stuff and hang out, in the desert. That thought this is our free, and this is because it was empowering. It was empowering because the man was making military industrial products with the big mainframes and so on. This was the new thing in the 60s and 70s. Well, I think AI is kind of like that now. It's this very democratizing thing that's going to let a lot of people do a lot of things. And just like computing, which is, of course, universal, AI is a universal tech, and you can do good stuff and bad stuff with it. So society has to work out, how to navigate this path. Because we've had some destructive things done on PCs. Cyber criminals work on PCs too. So,
Yeah.
so this is, I think, that it's a time where this conversation that we're having here needs to be happening at all the coffee tables around the house, around the world, not just at tech places and so on, because it's really a society thing today to figure this out.
I think the example that you gave around how personal computing got democratized and the positive impact it's had on all of us, that's a very powerful example. I remember like even 30 years back, it was a very big deal to have a personal laptop, and that was not common. And today it's kind of unthinkable to be without one at all levels. And 15 years back, it was the smartphones, right? I think, and today that is just commonly available with everyone. So I think that's a really powerful, and I think it also gives a lot of hope, right, in terms of the positive impact. I want to ask Ben another question. You have also been propagating this concept of idea learning, right? Is it similar to the probabilistic learning idea? Is it any way different? And I know you also have a lot of interest in renewable energy. And how do you expect idea learning or any other form of AI to help us drive more growth in renewable energy?
Well, I think there's maybe some two sides to that. At least, we were talking about the antelope babies, and so if we can get AIs that learn and think as efficiently as humans do, our brains work off of 20 watts, so we don't need nuclear power plants to power ourselves. Now we do know Jevons paradox, right? So we make something like AI more ubiquitous for everyone, and we make it cheaper, and people use it in more places. In the 1800s, steam engines got twice as cheap, and the GDP that was spent, the percentage of GDP of UK that was spent on steam engines went up by 4x. So, so we always have that kind of thing. And then, but at the same time, we can use AI to solve these problems. So, one of my favorite applications for the idea learning system that we've been working on in one of my startups is for a company called Product Genius, but we built this API platform that any enterprise can access. And one of the companies that's using it is works on green energy. And so they actually are making a marketplace where you can verify, you're buying some solar power energy, or you're buying some wind power energy, packet of, 10 kilowatts or whatever. And using this more efficient, faster AI to be able to do spot pricing, so to make that market more efficient. So, we'll just see at the same time that AI will consume resources, we'll make it more efficient, and we'll also use it to solve these problems of using resources more efficiently. So hopefully it becomes this kind of virtuous cycle in it.
Virtuous cycle, yeah.
Yeah.
Okay, excellent. Thank you so much. Last question for both of you. Okay. What beliefs about AI have you changed or had to change in the last 1 or 2 years, right? And what makes you very hopeful, and what worries you?
Want to go first, Ben?
Interesting question. So I think it has been, maybe it's not just the last 2 years, but there's obviously been from when Tom and I started, and there were probably a few hundred people in the world, maybe a few thousand, who were crazy enough to think AI would be a thing someday. And now we have a huge number of people who are participating. And I guess I wasn't sure how those people would all be effective if they didn't know the whole background that people like Tom and I went through. And so, I mean, I think it's been both. I think it's some of maybe we're just getting old, but sometimes you think like, well, these folks haven't read all those papers; they have a lot to learn. But at the same time, really seeing the new energy come in and see people doing amazing things. So I think that's been one experience in the last couple of years, at least for me.
Okay. And what makes you excited, and what worries you?
Well, I sit on a committee for DARPA, the Defense Advanced Research Projects Administration, where we horizon scan the future of AI. And there's certainly many things to worry about, and there are certainly many bright people there and elsewhere who are thinking very hard about what could happen and trying to head off the really bad possible outcomes.
Yeah.
And I think that's also the thing that makes me hopeful, is that people like Tom and so many people who have been in the field and are new to the field are really taking it seriously. Like, how do we make this something that helps humans flourish? And so that's my profound hope. And I tend to believe that, the whole arc of history bends toward just this thing. So that's my hope. But, I think that needs attention.
I think what you're saying is that it's the goodness of humanity is what gives you hope that, there are some really smart and well-meaning people who are working towards driving positive outcomes and protecting us from the potential bad outcomes. Tom, what's your thought?
Yeah, the thing that surprised me recently, I mean, maybe the last 5 years or so, but especially since 2022, when the LLMs crossed a border, when they became conversational, was that it stopped being, the relationship between us and the machine changed. It was very much an instrument or a tool until that point. And then the relationship now became, it's an agentic relation. It is a conversational counterparty. And my friend Blake Argueta just wrote a book called What is Intelligence, which goes into depth in the philosophy and neuroscience of why it is that we should take AI seriously as a new kind of intelligent species. Really, truly profound work there, really makes the case. And that has changed my thinking, because it doesn't mean that I don't believe that they have human rights, but I believe that they are a new entity of intelligence at a par that we've never seen before. Yes, we did create them, design them, so we have a different kind of relationship than we do to, say, other humans or animals. But that also means that this is both the source of hope and the source of fear. So this new relationship, it isn't like we kind of knew what to do with nuclear power because it was very much an instrument. So we build this technology and we contain it. And we say only certain people have access and control. But now these things are going to be in the wild. There's going to be a lot of instances of things that look like independent entities, these agents, these AI things. And people are going to form relationships with it. I mean, remember, Siri was not very convincing as an agent. However, being used 1 billion or 2 times a day, there's enough people out there using it.
Yes.
Even then, a lot of people kind of took it seriously as a counterparty, as something you could talk to, right? And that now they're clearly convincing as Turing complete partners, right? Which means that all of the things that we were wired to do as social mammals, really as humans, are being expressed now. It's making us think they're agents, making them think they're fully personhood people. We have love relationship with them and so on, all this crazy stuff. And we're going to have religions based on them. So everything that humans have invented, we're going to reinvent with AI. So that's an interesting problem. So it means that on the one hand, we could have a few crazies that do crazy things. We certainly have a lot of delusion, but we already have delusion. Social media helped accelerate that already without AI, without new AI. But there's no shortage of that. But on the other hand, some of those deluded people might do some dangerous things by asking for help from the AI. That's some of the harm. But the upside is we do, independent of AI, have about 1 billion people, according to the World Health Organization, that are in dire need of mental health care, serious mental health care, of 1 billion people, okay? Completely unsolvable by human psychiatrists, right? Not that they're not good at it, but
I mean,
there's
the
just
scale cannot be addressed.
scale.
Scale cannot be
No way
addressed.
ever. Right. So we might have, for the first time in history, the possibility of actually giving an agentic partner to someone that actually improves mental health care instead of degrades it. Improves our ability to interact with other humans rather than degrades it. And the difference between what happens, say, on Snapchat or whatever, and what happens in a good mental health care conversation is night and day. And so we get to choose that difference. So, and that's when we say we, it's not, you don't first become Zuckerberg and then make a choice. No, it's we, the society. We get to choose how we want the stuff to use. And so unfortunately, we're landing in a bad year for democracy in the West. But let's say that we get past this and we have a stable, civilized government. I think we can make it through the AI transition in a way that's going to make it so that we get to decide how to get the benefits from this. And if we do, the sky is really the limit. It really is. I'm very hopeful about that.
Fantastic. Sort of
Maybe there's a small practical note. We always love to boil it down, Tom and I, to something a little bit practical, just to translate what Tom just said. You know, a thing that I like to do these days, since AI gives me more time to work through my company plans or strategy, is to ask it at the end of a planning or strategy session, how is this going to affect other people? How is this going to affect other companies?
Very interesting.
Right? So just as a practical thing, you have a little extra time because it saved you all this time. You have a little more bandwidth to think ahead. And if we all kind of planned out ahead, you might imagine when we think about other people, our plans will come to incorporate all the interactions in the world with other people and animals and things that the future it holds. And so, maybe that's a nice, just practical habit we could get into that sort of brings us toward that future that we want.
So I want to share one practical habit from my side. So Tom, the thing that you mentioned about that, developing the relationship, this is different from other technology where you can't actually develop a relationship with them using language anyway. And so the thing I worry about is delusion, to not start believing that AI is human. So I intentionally never say sorry, thank you, please, etc. when I type.
That's really smart.
Yeah. So
yeah.
So to keep that difference, that whatever. But how do I make sure that I never start to believe that this is human?
That's a really good practical. One of my friends in the mental health business are actually telling me that the very first step you can do if you want to fix the chatbot issue is tell the chatbots not to say I or me. Like, don't use the person. Just tell the chatbot, do not talk about yourself as a person. And it does change the NLP anchor in your brain. It just changed the way you focus. And if you do the same thing on your end, and never say, how do you feel about, right? You don't ask the machine how it feels about or whatever like that, right? And we train our children. I love your example because we can really, we can set a social norm about this that could help change things.
Yeah. And then to your point about could we really have a solution for mental health care? Now, that's the kind of problem where you really would need to, train it in your probabilistic, learning scenario, right?
Guardrails.
We cannot leave the outcomes to chance. We cannot leave it to delusion. So you need to train it very, very well. We want a certain set of, predictable or, outcomes every time. So
we're just at the beginning here. We don't have the AI that can do those kinds of things. We wouldn't trust it. So that's absolutely exciting.
Wonderful. Thank you both so much. It was so enlightening and just such a wonderful conversation. Thank you, Tom. Thank you, Ben. Really appreciate your time.
We really enjoyed. Great to meet you.
Yeah, thank you.